Now we are discussing about voltage controlled oscillator. We have a specific IC for this, that is LM566. This is a 8-pin IC. In this IC, the pin configuration, we connect 1 to ground and pin number 8 to supply, and pin number 7 and pin number 6 we connect the external capacitor and resistors for the frequency control of the output of voltage controlled oscillator. 5th is the modulated input, and 3 and 4 are square wave and triangular output. For what purpose we are using this LM566? We are using this LM566 mainly for the generation of square wave and triangular wave outputs simultaneously. It is not that we are generating a square wave and triangular wave one by one. At the same time, simultaneously we can generate square wave and triangular waves at the terminals pins 3 and 4 with the frequency until 1 MHz. The maximum frequency is 1 MHz. The frequency of this signal, the output either square wave or triangular wave, frequency can be controlled by using either C1 and R1, and also the modulated input changes the output frequency. VCC also affects the output frequency definitely. Sinusoidal signal we can generate, but directly we do not get the sinusoidal signal from LM566. In order to get the sinusoidal signal, we have to connect the external circuit to the triangular wave output at the pin number 4. Then from this triangular wave output, sinusoidal signal can be generated. Here, if you see the entire block diagram of LM566, we have only these two components are connected outside of this box. One is R1 and the second one is C1. These two are connected in such a way that R1 is connected to pin 6 and also other end is connected to VCC. C1 is connected to pin 7 and other terminal is connected to ground. These two terminals, pin 7 and pin 6, are connected to capacitor and resistor. These two components R1 and C1 are deciding the frequency of the triangular wave output or square wave output. Initially this capacitor C1, it charges by using this constant current source. Now the question comes to us, what is this constant current source? We already discussed it. The current it is giving is constant. Because it is giving constant current, the capacitor rises linearly. The capacitor rises linearly from 0.25 VCC to 0.5 VCC. From this you can see. See here, the capacitor is rising linearly but not exponentially. Why the capacitor is rising linearly? Because of the constant current source we have supplied. Maximum value across the capacitor is 0.5 VCC and the minimum value across the capacitor is 0.25 VCC. So the capacitor rises linearly because we have supplied the constant current source. This constant current source can be controlled by using a external resistor R1 and also a modulated input VM. By using these two factors, we can control the current in the constant current source. This is providing the constant current. With this current, the capacitor is charging. And the capacitor is charging from 0.25 VCC to 0.5 VCC. This value we are giving to the buffer. Buffer will not it will not amplify the signal or it will not attenuate the signal, but it will pass the same input whatever it is getting as the output to the Next, operational amplifier A2. The buffer is connected to the inverting terminal of the operational amplifier A2. So the output of the buffer is a triangular wave. Whatever the capacitor here getting, the same signal buffer is giving. The output of the buffer is a triangular wave. So that's why the output of the buffer we have connected to the pin number 4. This is a triangular wave output. So simply this capacitor is giving the triangular wave output because of the constant current source. You have connected the constant current source to the capacitor. Capacitor is charging from 0.25 VCC to 0.5 VCC. And it is discharging from 0.5 VCC to 0.25 VCC. So the charging and the discharging of the capacitor is creating the triangular wave. A capacitor with a constant current source. When the capacitor is charging because of the constant current source. When the capacitor is discharging through the resistors RA and RB. During both these times, when the capacitor is charging and discharging, you remember, the voltage is maintained from 0.5 VCC to 0.25 VCC only. The maximum peak is 0.5 VCC and the minimum value is 0.25 VCC. So the triangular wave which we are getting, the maximum value is 0.5 VCC and the minimum value is 0.25 VCC. This triangular wave we are feeding as input to the Smith trigger. Smith trigger we have already learned. The output of this Smith trigger is nothing but a square wave. This Smith trigger, we have given the triangular wave input at the inverting terminal of the operational amplifier A2. So when capacitor is charging from 0.25 VCC to 0.5 VCC, then the output of this Smith trigger will be voltage level high. So this will be high. This will be the input to the inverter, we will discuss later. So this is a square wave high. And when capacitor is discharging, this will be square wave low. So the Smith trigger is having only two values, either high square wave or low square wave. High level voltage, low level voltage. When the capacitor is charging, the voltage is high. When the capacitor is discharging, the voltage is low. The Smith trigger output oscillates between the two values, the high voltage and the low voltage, depending upon whether the capacitor is charging or discharging. When the capacitor is charging, the output will be high, and when the capacitor is discharging, the output will be low. Only two values, whether it is high or low. That will be depending upon the whether your capacitor is in charging state or is it in discharging state. So here the capacitor is charging. That's why the output will be high. Here the capacitor is discharging. That's why the output will be low. Again capacitor is charging. Output will be high. Again capacitor is discharging. Output will be low. But this Smith trigger output, we are connecting to inverter. Inverter means whenever this Smith trigger is giving the high voltage, your inverter will give the low voltage. And similarly, whenever your Smith trigger is giving low voltage, your inverter will give the high voltage. Exactly opposite. So the output of the inverter is a square wave. We are getting two signals. One is a triangular signal and the second one is square wave. These two signals of frequency can be controlled by using this formula, 2 into VCC minus VM by R1 C1 VCC. Means the output signal frequency can be controlled by using the resistor R1 and the capacitor C1 and also the VCC and the modulating input. The output can be controlled by using the modulated input, the external voltage. By using that we can control the output signal frequency. So once again, we are trying to discuss the operation of this circuit. The circuit operation is very much simple. We already discussed voltage controlled oscillator. For that we have taken a IC LM566. The purpose of this IC is to generate square wave and sinusoidal wave and triangular wave. It generates square and triangular waves directly, and indirectly by using this triangular signal we can generate the sinusoidal signal also. Now we are discussing the process. We are using two external components R1 and C1. This capacitor is the main element for the charging and discharging, which will decide our triangular wave. This capacitor is connected to constant current source. Because of the constant current from this constant current source, the capacitor voltage rises linearly instead of exponentially. In order to rise the voltage across the capacitor linearly, we are making the current is constant. And whenever the capacitor is rising from 0.25 VCC to 0.5 VCC, then the Schmitt trigger output will be voltage high. And whenever the capacitor is falling, what we call as a discharging. Whenever the voltage in the capacitor is falling from 0.5 VCC to 0.25 VCC, which is nothing but when the capacitor is discharging through the resistors RA and RB, then the voltage output at the Schmitt trigger will be low. So this will be observed by using this graph. When the capacitor voltage is rising, then the Schmitt trigger output will be high. When the capacitor is discharging, then the Schmitt trigger output will be low. When the Schmitt trigger output will be high, the inverter output will be low. When the Schmitt trigger output is low, the inverter output will be high. We are generating triangular wave and square waves. The capacitor is directly giving the triangular wave. At this, by using the Schmitt trigger, we are getting the square wave, and the same thing we are getting at the inverter. Where we use this circuit? We use this circuit in the frequency shift keying, in the frequency modulation. In the frequency shift keying, whenever we want to use the carrier in such a way that to change the frequency for the binary 1 and binary 0, at that time we may use the voltage controlled oscillator. And for the signal generation, for the triangular wave and square waves, we will use this circuit. This is the operation of the voltage controlled oscillator.